Hi everyone, I'm Simon from ZKNOX, and I'm going to present something related to hardware wallet integration for privacy-preserving protocols. So it's a work I've done with my colleague Renaud from ZKNOX, and we were collaborating with RAILGUN. So just to present our company briefly, Nicolas was one of the co-founders of Ledger. So for the people who know hardware wallets, they probably know Nicolas. And Renaud and I are more in the cryptography side, so implementing some privacy-preserving protocols and also other stuff related to post-quantum cryptography, for example. So we try to implement things on the hardware wallets, but also on the chain, so writing smart contracts, and we try to have an overview of all the cryptography related to the blockchain. So if you're interested in our work, everything is open source, so you can go to our GitHub to check. So now I'm going to explain what we implemented in the hardware wallet. So just to give a brief overview of what is needed in the privacy-preserving protocols. For example, in RAILGUN, when Alice wants to send some money to Bob, she needs to create a nullifier and then create a ZK proof related to some commitment in a Merkle tree. A lot of things that I won't detail here, but at the end, there is one proof that is computed and one signature that is also computed outside of the ZK proof. And this signature needs to use the secret key of the account of Alice. And this is what we want to compute on the ledger so that we don't lose the funds if someone steals the private key. So we target this signature generation on the ledger, on the hardware wallet. So as I said, you need to use the secret key. And if you use today RAILGUN, you are not able to use the hardware wallet because you need to use the software to compute this signature. So if you want to implement this on a hardware wallet, you have basically three options between Ledger and other hardware wallets that are available. But the thing is that this signature is not a common signature as in Ethereum or Bitcoin. You need to use a custom elliptic curve that is designed so that the ZK proof is efficiently computed. And the hash function is also chosen so that this ZK proof is efficient. So if you want to implement this if you want to use a ledger to compute this signature, you won't be able to use the algorithm that they provide, but you rather need to implement this signature. So what we did is that we decided to use the ledger for now because it has an open source option to write your own application, which was a bit easier than other hardware wallets. And we implemented this signature computation on the ledger using a flex like this or any ledger wallet. So I'm not able to show directly on my laptop, but it's a very ugly cryptographer design. So I will rather show what you would see on the ledger. So you just, when you want to sign your transaction on RAILGUN, you would see like just a display as a normal review transaction. Then you would see the hash of the transaction that you want to sign. So everything related to the commitment of the RAILGUN transaction. Then you can check from the wallet, the hot wallet, and the transaction hash displayed on the ledger. From that, you would sign the transaction as a common Ethereum transaction, and the signing process works. And then you can use the hot wallet to process the transaction. So if you want an integration, you can ask Zion that is here. He has a very good UX that lets you use the hardware wallet to sign a transaction. And it's going to be soon integrated into Kohaku Wallet, which is a project by the Ethereum Foundation trying to push privacy-preserving protocols into wallets. So just to conclude and to summarize what we did, we provide a hardware implementation of this signature computation on the ledger. So we have an implementation of this specific elliptic curve, BabyJubjub, and also a generic implementation so that you can switch to other elliptic curves that are also used in other blockchain or other protocols. We are almost done for implementing the Frost signature scheme, which is a way to have like a multi-signature using the same backend, and to be able to use, for example, a hot wallet and a hardware wallet to sign one transaction. We still have a bit of work to get optimized scalar multiplication, but it's already quite fast actually to sign with a ledger. If you want to check, I can show you, but it's only less than 3 seconds, I think, for signing a transaction. We don't have the derivation of the secret key fully implemented because we need the access to the secure element, which we can't do now, but Ledger have to do this BIP32 derivation to let us make it work. And of course, we need to integrate this into Kohaku wallet, and this will be made public soon, I think. And yeah, that's it. Thank you for your attention.